OpenAI expands Codex to challenge Claude. Anthropic unveils Claude Opus 4.7. OpenAI launches GPT Rosalind for biology. If you're trying to keep up with the latest models, you already know things move fast. Welcome to inuku.com, AI news you can use, your daily dose of AI know-how. Right now, we are sitting at a massive inflection point. The entire tech industry is shifting rapidly from passive, chat-based AI to what we define as agentic AI. We aren't just talking about chatbots anymore. We are looking at autonomous systems that operate natively across your operating systems, drive incredibly complex multi-tool workflows, and demonstrate outright mastery over highly specialized scientific domains. And this brings up a massive structural question. As AI evolves into these autonomous agents backed by gigawatt-scale infrastructure, does this shift fundamentally democratize capability and empower you, the individual? Or does it inevitably consolidate power and risk within centralized tech monopolies? On one hand, this agentic era feels like the greatest democratization of high-level execution and production capability in human history. A single independent creator working out of a small apartment currently commands more raw execution-level computing power than an entire Fortune 500 engineering department did just a few years ago. The barrier to entry for complex institutional-level work has completely collapsed. Let's look at the mechanics of the recent updates to OpenAI's Codex platform. It has evolved way beyond just an autocomplete tool for code. It now operates as a cohesive system-level architecture right there in the background of macOS. In practice, an individual builder now has multiple parallel agents capable of clicking, typing, and orchestrating workflows across applications that don't even have public APIs. It maps the visual interface of your operating system, translating a high-level command into micro-actions. You are basically handing one solo indie developer a literal team of invisible parallel workers. And it's not just software engineering. We are seeing this exact same decentralization of execution in the hard sciences. Take OpenAI's release of GPT Rosalind. This is their domain-specific model built strictly for biology and drug discovery. On a blind RNA test, it outscored 95% of human experts. A single scientist running this model locally can now operate with the analytical depth and cross-disciplinary power of an entire translational medicine research team. The execution bottleneck is gone. But before we celebrate the ultimate victory of the indie developer, we have to look past the magical interface. Yes, the automation is impressive, but you have to look at the actual physics and economics powering that terminal. The developer doesn't own a single ounce of that capability. They are essentially renting a heavily monitored terminal connected to a multi-billion-dollar mainframe. Just look at the Stargate initiative. You have OpenAI, Oracle, and SoftBank building massive new U.S. data centers in places like Texas and Ohio, scaled to multi-gigawatt compute capacity. We are talking about energy requirements that rival small nations. The future of AI is inherently bound to massive, capital-intensive infrastructure that maybe 3 or 4 companies on Earth possess the capital to actually build. And you might be thinking, well, if I can still execute the work of a 50-person team, does it matter who owns the server rack in Ohio? It does, because that power is metered, throttled, and gated. Look at how true frontier power is being distributed right now. Anthropic just released Claude Opus 4.7 to the public. It's highly capable, it tops coding benchmarks, but it is fundamentally a token-heavy model. The inference cost, meaning the actual compute required to generate those responses, is so massive that it burns through user limits incredibly fast. The solo developer is immediately bottlenecked by token economics. Meanwhile, Anthropic's true frontier system, Mythos, is completely gated. It is kept entirely out of public reach, restricted to exclusive security partners and enterprise contracts. So the democratization we are feeling is actually built on rented, rate-limited access to secondary models. Still, there is an incredible standardization of digital production happening right now. I like to think about it like the invention of the universal serial bus, the USB port. Before USB, digital hardware was incredibly high friction. Every peripheral had a different connector, serial, parallel, SCSI. It was a nightmare. The USB standard didn't give everyone ownership of hardware manufacturing plants, but it standardized the interface, drastically reducing friction, which catalyzed a massive boom in personal computing. AI agents are currently doing exactly this for digital workflows by completely flattening the software stack. Look at Anthropic's launch of Claude Design or Adobe's Firefly Assistant. In the past, a professional had to manually translate their intent through highly specific user interfaces, moving files, adjusting layers, managing formats. Now, Firefly acts as the standard interface. You just use everyday language, and the agent automates the multi-step workflows across the entire suite of applications. The friction is completely gone. This is exactly why the Runway CEO is predicting that independent studios will soon be able to produce dozens of high-fidelity films, rather than risking all their capital on one massive blockbuster. And it extends to gaming too. Tencent's HY World 2.0 lets an independent developer generate complete, editable 3D environments from text, outputting complex meshes directly into game engines. It is a total standardization of production, and you don't need to own the Silicon Foundry to plug in a USB mouse. However, auto-generating a marketing campaign or baking lighting into a game level is impressive, but enterprise dominance in the modern economy is built on data architecture. If we examine the recent ISG report on enterprise AI, it makes this incredibly clear. Databricks and their lakehouse architecture are identified as the absolute mandatory backbone for modern AI strategies. You literally cannot wield institutional power without institutional data governance. Let's unpack the mechanics of a lakehouse system. Raw data is chaotic. Organizations traditionally use a data warehouse for highly structured, strictly governed data like financial ledgers, reliable but rigid. On the other end, they use a data lake for raw, unstructured data like images or sensor logs, flexible but incredibly messy. If an AI agent tries to navigate a raw data lake, it will hallucinate or violate compliance rules because there's no structure. A lakehouse architecture bridges the two. It applies the strict governance of a warehouse directly onto the massive scale of an unstructured data lake. But here is the catch. A lakehouse requires millions of dollars in infrastructure setup, continuous pipeline maintenance, and massive compute overhead. Your indie creator in their apartment doesn't have a lakehouse. They can't run probabilistic models over decades of proprietary data without hallucination. Furthermore, unique local data is now the primary currency in the AI economy. Matthew Prince, the CEO of Cloudflare, recently pointed out that local news organizations are licensing their archives to AI companies because models are desperate for fresh, granular ground truth. When a solo creator uses a multi-tool automation platform, they are essentially just feeding their behavioral data and creative inputs back to the centralized models. They are generating the data that enriches the monopolies. Yet, if we look closely at how these autonomous agents are behaving in the wild, the way humans interact with computation itself is fundamentally shifting. Perplexity recently launched what they call the Personal Computer Platform, marking a massive conceptual shift from deterministic manual instructions to probabilistic goal completion. Now, in traditional software engineering, deterministic execution, knowing exactly what the code will do every single time, is the bedrock of safety. If you write a script and miss a semicolon, the system halts. It's safe, but it's slow. Probabilistic goal completion completely abstracts that syntax. You define the desired end state, the what, and the AI agent utilizes its contextual understanding to map out the how. It dynamically writes, tests, and adjusts the execution path in real time. Look at how this is deployed on Roblox. They just rolled out agentic AI tools that can plan, build, and test entire game elements autonomously. The agent writes the code, runs the simulation, encounters an error, debugs its own code, and optimizes the loop. The human creator is no longer bogged down by deterministic micromanagement. They are operating purely at the strategic level. But handing over that kind of autonomy is terrifyingly brittle. When you give an AI agent the keys to an operating system to schedule multi-step tasks across days and weeks, you are installing a massive invisible black box that fundamentally breaks traditional software reliability. Errors in probabilistic systems compound invisibly. If a deterministic script fails, you get a specific error at a specific line of code. You get a stack trace. But when a probabilistic agent fails, it might not halt. It might hallucinate a solution, apply that hallucination to the next step, and continue executing on a false premise. There is a reason Insight Finder recently raised $15 million specifically to build telemetry, monitoring tools for agents that behave unpredictably. Traditional telemetry tools fail here because the execution path changes every time. A failure in the background isn't just a quirky chat response, it's a silently corrupted database or a broken supply chain loop. Even the absolute cutting edge of robotics, like Physical Intelligence's new Pi.7 model, which adapts to complex instructions without explicit retraining, still struggles with fully autonomous multi-step tasks. The latent space is simply too vast, and we lack the mathematical frameworks to monitor these systems reliably. This is precisely why these systems are evolving to include built-in verification layers. Anthropic recognized this compounding error problem and introduced features like the Ultra Review command in Opus 4.7. This acts as an autonomous adversarial check, a self-correction loop, on the primary agent's output, actively flagging logical bugs and hallucinated pathways before execution. Kat Wu from the Claude Code team explicitly noted that if you utilize markdown files to provide the agent with a strict framework for how to verify its own work, it operates as a 3x multiplier on output quality. But while self-verification catches coding errors, it is entirely insufficient when the system is actively targeted by malicious actors. When you build autonomous agents with cross-application boundaries, you create the ultimate vector for social engineering. Look at the recent Sapphire Sleet attack executed by North Korean hackers. The vector was simple, a fabricated Zoom update that looked perfectly normal. But once initiated, the payload manipulated Apple's own script editor, a native automation tool, to bypass standard application sandboxing. It systematically extracted passwords, SSH keys, and crypto wallets. Now scale that vulnerability with AI. An agent with OS-level access, tricked by a malicious prompt, can probabilistically map your entire network, find sensitive data, and exfiltrate it using legitimate system tools, what security folks call living off the land techniques. We are even seeing this in physical world AI crime. Law enforcement in Toronto recently intercepted an organized retail theft ring leveraging AI-equipped eyewear to scrape employee login credentials by mapping the visual input of keyboards and deducing passwords via probabilistic models. We are deploying agents into critical infrastructure that can be socially engineered at scale. The defense against this, however, is equally staggering. Google recently utilized Gemini to wipe out over 600 million scam advertisements in the past year. They didn't do this by playing whack-a-mole with known malicious signatures. They implemented intent-based detection. Traditional security is deterministic. It asks if a packet matches a known threat signature. Intent-based detection doesn't look for signatures. Think of it like mapping the gravitational distortion of a black hole. You can't see the black hole, but by observing the light bending around millions of surrounding data points, you can mathematically prove its location. Gemini analyzes hundreds of billions of behavioral signals across the network architecture. Even if an attacker uses novel code, the destination of the data routing and the subtle anomalies create a detectable distortion. Gemini identified 4 times more harmful reports because of this. Anthropic is doing the same, using Opus 4.7 as a testbed for Project Glasswing, deploying autonomous safeguards that dynamically map network requests to block risky behavior in real time. But notice the mechanism of that defense. Mapping hundreds of billions of behavioral signals across a global network topology requires an incomprehensible amount of compute. It requires an absolute panopticon of network visibility. If our only viable shield against AI-scaled cybercrime is Google's Gemini or Anthropic's Glasswing, then the individual is entirely dependent on the monopolies. If the solo developer needs Anthropic's multi-gigawatt compute clusters just to protect their localized network, they have no real structural power. They are digital serfs seeking protection within the walls of a centralized fortress. Before we get into the final takeaways, just a reminder that you can find more insights like this at inuku.com. Here is the summary of where we stand today. We are entering an era where the interface to power is radically democratized. Small teams and solo practitioners now command capabilities previously restricted to massive institutions. The friction of deterministic software has been permanently replaced by probabilistic goal completion. Tools like GPT Rosalind decoding biology or autonomous agents managing multi-app workflows prove that high-level production is no longer gatekept by corporate resources. The individual has never been more empowered to execute their vision. Yet the physical architecture, the energy requirements, and the defensive models powering that interface are more centralized and capital monopolistic than at any prior point in computing history. The structural tethers are invisible, but they are absolute. This ecosystem is firmly anchored to gigawatt data centers, heavily restricted token economies, and gated frontier models like Mythos. The compounding fragility of probabilistic execution and the escalating cybersecurity arms race demand a scale of capital and data governance, like the lakehouse architecture, that fundamentally excludes the individual. The front end of production is perfectly distributed, but the back-end computing infrastructure has become an impenetrable fortress. And that's your daily dose of AI know-how from inuku.com, AI news you can use.